Hello everyone, welcome back. Today we are doing Elasticity, which is chapter 6 from our textbook, and I'm using Microeconomics by Krugman, Wells, and Parkinson, and it is the 4th Canadian edition. Now, elasticity. What is elasticity? In order to see that, let's look at an example. You'll observe that the cost of an ambulance ride varies widely across Canada. It could be anywhere from $45 to several $100s. So you should be asking yourself, what accounts for this extreme variation? Why are some people paying a lot less than other people for the exact same service? Now, the answer lies in the responsiveness of consumers to price, or what we call the price elasticity of demand. We can calculate the price elasticity of demand by simply taking the ratio of the percentage change in quantity demanded to the percentage change in price. This will calculate the responsiveness of quantity demanded due to 1% change in the price of that good. Elasticity of demand will always be a negative number because the law of demand tells us whenever price goes up, quantity demanded goes down. So we'll typically ignore the negative whenever we are looking at the strength of price elasticity of demand. So in order to look at the absolute value, we'll be dropping the negative. Let's look at the mathematical definition of elasticity of demand. Remember, it's the percentage change in quantity demanded to the percentage change in price. So how do we calculate percentage change in quantity demanded? It's simply the change in quantity demanded. So Q2 minus Q1 divided by the initial quantity demanded. So in our case, let's say that was Q1. Percentage change in price would be similar. P2 minus P1, so the change in price divided by your initial price. And taking these two percentage changes separately and then taking the ratio will give you the price elasticity of demand. I'll use this notation for our price elasticity of demand. So it's simply the percentage change in quantity demanded divided by the percentage change in price. This is the mathematical formula, and let's look at now an example and apply it over here. Here I have the demand curve for vaccines, and the price of vaccine is going up from $20 to $21 per unit. And as a result, you can see quantity demanded for vaccines has gone down from 10 to 9.9 million units. As a result of this change from A to B, we can now calculate the price elasticity of demand. If we use the correct mathematical formula for percentage change, we'll be looking at, as we move from A to B, point A to B, as price rose from 20 to 21 and quantity demanded fell from 10 to 9.1, what is the percentage change in either of these variables? So the percentage change in quantity would be 9.9 minus 10 divided by your initial value of 10, and then the new price over here, 21 minus 20 divided by your initial price of 20. Note, when we use this mathematical formula and we are moving across 2 points on the demand curve, in our case those were A and B, our price elasticity of demand will be dependent upon what was the initial value. So between these 2 points, this is your initial value. In case of quantity, that was 10. In case of price, that was 20. If I was to calculate elasticity instead between B to A, now your initial values will change. Note that the change in price and change in quantity are the same, but your initial values are now different. As you're moving down along the demand curve, your initial price is 21. And your initial quantity is 9.9. Depending upon how big the difference is between these 2 points, your initial values can be very different and can have a huge impact on the price elasticity of demand between any 2 points, depending upon whether you're moving down along the demand curve or you're moving upwards along the demand curve. So here, there's a small difference, 9.9 and 10 in terms of the initial price, or 20 versus 21. But note, it could be significantly different. So every time you calculate price elasticity of demand, you'll have to figure out, am I calculating it moving downwards along the demand curve or upwards along the demand curve? In order to get rid of this ambiguity, we will use what we call the midpoint method for calculating price elasticity of demand. So please note, you're expected to use the midpoint method, also known as the arc elasticity method. In the arc elasticity method, we will take the percentage change in the variable using the average value or the midpoint of those two values. So the percentage change in a given variable would be the change in that variable relative to the average value of that variable. Let's put that in writing. So we are now calculating percentage change in some variable x. So that would be change in value of x, so x2 minus x1 divided by the average value of x. How do you calculate an average value of a variable? It's simply the starting value plus the final value. So add the two numbers and divide it by 2. So now your percentage change in variable x is change in x divided by the average of x times 100. We will now use this instead of the initial value when we are calculating percentage change in quantity demanded or percentage change in price. So percentage change in quantity demanded is change in quantity divided by the average quantity. Percentage change in price is calculated as change in price divided by the average price. And once you have these two percentage changes, take the ratio and you'll get your price elasticity of demand. So let's look at an example over here. We have initial price of $2.85 and quantity demanded is 15,000 units. As price rises to $3.15, quantity demanded falls to 11,000 units. Can you calculate price elasticity of demand using the midpoint method or the arc elasticity method? I would advise you to pause the video here, solve it on your own, and then proceed and look at my answer. So let's use our formula to calculate price elasticity of demand. Quantity fell from 15,000 to 11,000. So this is your percentage change in quantity, but this is now calculated using the midpoint method, change in quantity divided by the average quantity. And remember, price went up from $2.85 or $2.85 to $3.15. So this lower is your, or the denominator over here is your percentage change in price. And again, we are using both of them using the midpoint method. Once we have calculated the two percentage changes, you can see quantity demanded has decreased by 31%. Price has increased by 10%. So for every 1% change in price, quantity demanded fell by 3.1%. Now, elasticity of demand will always be negative. Taking its absolute value or dropping the negative, it gives you a number of 3.1. Note that elasticity is unit free. When we take the ratio of two percentages, it is essentially unit free. Elasticity has no unit. So you do not write a percentage sign against your final answer. We are interested in the magnitude of our price elasticity of demand or its absolute value. Why? Because this will reveal how responsive is quantity to any given change in price. So here are some examples next for different type of elasticity measures. We have eggs with an elasticity of 0.1, beef 0.4, stationery 0.5, and gasoline again 0.5. These are all note elasticity measures which are less than 1. Here I have another group of goods for which elasticity of demand is higher than 1. Again, remember, we are ignoring the negative, so these are absolute values, so we can capture the magnitude of elasticity. Housing, restaurant meals, airline travel, and foreign travel all have price elasticity of demand which is greater than 1. Whenever your elasticity measure in its absolute value is less than 1, we'll call it inelastic demand. And whenever your price elasticity of demand is greater than 1 in absolute value, we'll call these goods as having elastic demand. What do we mean by inelastic? Inelastic is telling you that this ratio is less than 1, indicating to you that for any given change in price, percentage change in quantity demanded is less than the percentage change in price. So for example, if price rises by 10%, quantity demanded in these goods will fall by less than 10%. Or if price decreases by 10%, quantity demanded will increase by less than 10%. Quantity demanded for inelastic goods is less responsive compared to goods which have elastic demand. Elastic demand is always giving you price elasticity of demand greater than 1. So we can rewrite our formula over here. But now this ratio is bigger than 1. So it immediately tells you that whenever price changes by 1%, quantity demanded increases or changes in response to that by more than that increase or change in price. So percentage change in quantity demanded will always be more than the given change in price over here. So a lot more responsiveness quantity demanded for these goods like housing, restaurant meals, airline travel, foreign travel, etc. These are just examples of goods having typically elasticity measure which is greater than 1. Now, what determines responsiveness of quantity demanded to a given change in price? What makes elasticity of demand relatively inelastic or more likely to be elastic? Now, we have some determinants of elasticity of demand. Note that the first one over here is close substitutes, availability of close substitutes. If a good has many substitutes available and price increases by 1%, as consumers, you will just easily switch to other substitutes or the alternatives for that particular good. So here you'll see for a given change in price, quantity demanded will respond very quickly or very sharply. So we'll typically see elasticity measure in its absolute value to be relatively higher. Higher the number of available goods which are substitutes for that good, typically more responsive is quantity demanded for that good. Whether the good is a necessity or a luxury. So how do we perceive the good as a consumer? If the good is a necessity for me, my responsiveness will be relatively low compared to when the good is deemed a luxury by myself. So for necessities, even if price goes up by 1% or 10%, I will respond not as much to that given change in price. So you'll see relatively for necessities, price elasticity of demand will be relatively lower, and for luxuries, price elasticity of demand would be relatively higher. For luxuries, if there is a huge percentage change in price, you will typically are less likely to buy the good. So quantity demanded responds very quickly, a drastic decrease in the quantity demanded for this good for a given change in price, because people do not need this good, unlike the necessities which they have to buy. Third one is your share of income spent on that good. If the share of income spent on the good is relatively small, then the price elasticity of demand is also going to be relatively low. If the share of income spent on the good is relatively large, so a big chunk of your income is going into that particular good or in order to purchase that good, in that case, the price elasticity of demand is also going to be relatively higher or bigger than 1. So for example, you can look at the example of table salt. A box of table salt costs you around $2, and let's assume the price increases to $3. That's a significant change in the price of this good, let's say 50%. For this 50% increase in price, do you stop buying table salt? Very unlikely. So you'll see, because it costs so little and it has a very small percentage share of your overall income, you're less likely to respond to this price change. It doesn't really affect you. However, if it was costing you $200 and it's increasing to $300, now that's a significant share of your monthly income, and you are now less likely to still consume the good, or you're going to think about reducing the consumption of that particular good. So smaller the share of income spent, the lower is elasticity of demand. So smaller share, lower elasticity of demand. You don't respond as much. Bigger the percentage share of income spent on that good, more high is going to be the price elasticity of demand, and therefore more responsive is your quantity demanded to a given percentage change in price for that particular good. The last factor is time. Note that your number of substitutes available for a particular good may change over time. The nature of the good may change over time. It might become a luxury for you or it might become a necessity for you. And of course, your income may change or the price of the good may change. So the percentage share of income spent on that good may also change over time. So time is not constant. Things do not remain constant over time. So you can see over time, price elasticity of demand may change. So elasticity is not stuck at a particular number over time. Because of these underlying factors, price elasticity of demand can become higher or lower, making the good relatively inelastic or relatively elastic. Now let's interpret the price elasticity of demand using some extreme cases. Here I have what we call perfectly inelastic demand. Perfectly inelastic demand is telling you that quantity demanded is not responding at all to a given change in price. Now, if you are seeing relative increases in prices, from $10 to $20 or $20 to $100, regardless of the change in price, quantity demanded is not responding at all. Visualize the shape of such a demand curve where quantity demanded is not changing to any given price change. You'll note that you'll end up seeing a vertical demand curve. The other opposite extreme would be the perfectly elastic demand. In the case of a perfectly elastic demand, now your quantity demanded is extremely responsive. If price goes up by a small amount, quantity demanded will immediately fall to zero. So again, try and visualize the shape of this particular demand curve where quantity demanded is responding extremely quickly or rapidly for even a small change in price. In the first one, you'll end up with a vertical demand curve. Remember, in the perfectly inelastic demand, price is going up, but quantity demanded is not changing at all. Here, the price of antivenom is increasing from $2 to $3, and quantity demanded is stuck at 1, or in this case, 1,000 doses. Note that for most pharmaceutical drugs, like insulin, cancer drugs, etc., because patients have to have those things or those goods, quantity demanded is not responding at all to any given change in price. So for these type of goods, demand is relatively inelastic, and in the extreme case, it is perfectly inelastic. When we have perfectly inelastic demand, the elasticity measure is equal to 0. There's no change in quantity demanded to a given change in price. So percentage change in quantity demanded is equal to 0, making your ratio equal to 0. The other extreme case was perfectly elastic demand. Now you can say that the demand curve is horizontal. It's parallel to your horizontal axis. Why is it horizontal? Because note here, if price rises by even a small amount, quantity demanded immediately drops to 0. So in our case, the example is of pink tennis balls, a very specific type of item. So with this specific item, people are willing to pay $5 and you buy unlimited amounts of this good. But if price rises from $5 to $5.50 or $6 per unit, quantity demanded immediately drops to 0. So your quantity demanded is responding very, very quickly, or rather drastically, making your elasticity measure equal to infinity. Note the elasticity measure was percentage change in quantity demanded to percentage change in price. Now if this rises by a small amount, this is immediately dropping to 0. So we have elasticity measure equaling infinity. Other than the extreme cases, price elasticity of demand can vary from anywhere between 0 and infinity. But specifically, if it's greater than 1, we call it elastic demand. Elastic demand is telling you that for any given change in price, or for example, a 10% increase in price, quantity demanded will increase by more than 10%. Then we have inelastic demand. Remember, inelastic demand was when it is not as responsive to any given change in price. So now the measure will be less than 1, indicating to you specifically that for any given change in price, quantity demanded responds by less than that percentage change. So for example, a 10% increase in price will cause quantity demanded to decrease by less than 10%. And then of course we may have a situation where you have unit elastic demand. Here the price measure or the elasticity of demand measure is exactly equal to 1, and that is telling you that percentage change in price causes the percentage change in quantity demanded to be exactly equal. So quantity demanded responds to change in price by exactly the same amount. For example, if price rises by 10%, quantity demanded will now fall by 10%. The elasticity, remember, is always negative, elasticity of demand, but we are ignoring the negative in this case because we are focusing more on the magnitude of elasticity, or by how much is it responding to a given change in price. Let's look at these different type of demand curves on our diagram. So here I have a unit elastic demand curve where the elasticity of demand is equal to 1. When price rises from 90 cents to $1.10, quantity demanded is falling from 1100 units to 900 units, and that's movement along the demand curve from point A to point B. Now this is a 20% increase in price, and this is also causing quantity demanded to decrease by 20% as well. So you can see the ratio of elasticity with the price elasticity of demand over here will be exactly equal to 1. Next we have a relatively steep curve. Now along the steep curve, we'll again increase the price from 90 cents to $1.10. So same as before, a 20% increase in price between point A and B. However, now as we are seeing a 20% increase in price, quantity demanded is falling from $10.50 to $9.50, which is only a 10% decrease in quantity demanded. Now if we take the ratio, you'll see that price elasticity of demand is less than 1, and to be specific, it will only be 0.5. Thirdly, we have a situation where the demand curve is now relatively flat, and here again we're increasing the price from 90 cents to $1.10, and that's again movement from A to B respectively on this particular curve. And in response to this 20% increase in price, note that quantity demanded is falling by a huge amount from 1200 to 800, which would be specifically a 40% decrease in quantity demanded. Taking the ratio 40% divided by 20%, that gives you price elasticity of demand of 2. So note that your price elasticity of demand is also determining the relative shape of the curve that we are working with. With relatively inelastic demand, we are working with steeper curves. With relatively elastic demand, we are working with relatively flatter curves. So if I compare the two side by side, you can see with this inelastic demand curve where elasticity measure was 0.5, I have a much steeper curve. And when I have price elasticity of demand equaling 2 for, 20% increase in price over here, exact same increase in price, but now quantity demanded is responding by a lot more. So a much flatter curve whenever you're working with a relatively elastic demand curve. Now, why is elasticity useful? We know that whenever we raise price, quantity demanded goes down. That's your basic law of demand. But by how much does the quantity change? Firms are really interested in that question when you are trying to raise prices for certain goods or you're trying to put certain items on sale. You want to know how will your consumers respond. So what type of incentive should you give your consumers? Will you, by increasing the price, lose a lot of your customer base? In that case, you should not be perhaps, changing that price or increasing that price. If by reducing the price, you will increase a lot of your sales, that might be advisable because in that case, your revenues might increase drastically. Note that quantity demanded is moving along the demand curve. So the relative steepness, flatness, or specifically elasticity of demand is extremely useful for firms in order to determine what will happen to their revenue. How is revenue affected because of a given price change? So here I have an example of a cafe where a typical cup of coffee or cappuccino is selling for $3 a cup. Now, if you're selling 15 cups, your revenue is $45. You're contemplating as the owner of this cafe, should you increase the price from $3 to $5? Now, you know that as the price goes up, quantity demanded will definitely fall. So you will lose some sales. What you want to focus on is, as a result of the sales, what will be the impact on my revenue? Remember, revenue is price times quantity. And as you're increasing the price, there is an opposite effect on revenue. Now, coming from your reduction in sales. Elasticity of demand will determine which of these effects is the dominant effect. If the price effect is dominant in this particular scenario, your revenues will definitely increase. However, if the quantity effect is dominant, you lose a lot of sales because of this $2 increase in your cup of coffee. Now you will end up losing significant revenue and maybe you should rethink your decision. So we'll next see the impact of elasticity of demand on the revenue for firms. Now we can also look at the scenario from the point of view of customer base. For customers, the total amount that they spend on coffee is what we call total expenditure. Total expenditure is again price times quantity. So higher the price, lower is the quantity demanded, and expenditure can again have two opposite effects. Your overall expenditure can increase if the price effect is dominant in this case, or your overall expenditure can decrease if you start consuming a lot less of this good compared to before. So revenue and expenditure are two sides of the exact same coin. From the point of view of firms, this concept is total revenue, and from the point of view of our customers in this market, this concept is total expenditure. So I'll focus more on total revenue. So from the point of view of firms, how elasticity of demand will affect revenue for firms and help them in their decision making. So depending upon whether we are working with unit elastic demand, inelastic demand, or elastic demand, we want to see the impact on the revenue or the total value of sales that the firm is selling or the producers are selling in this particular market. Note, whenever price increases, quantity sold will decrease, and whenever price decreases, quantity sold will increase. So we have two opposite effects on revenue coming from price and quantity sold. Here I have a diagram for a demand curve, which is giving you a total revenue of $990. How are we calculating revenue? It's simply price times quantity. At price of 90 cents, we're selling 1100 units in this market and our total revenue is 990. As price increases from 90 cents to $1.10, note there is now two opposite effects on revenue. Because I'm increasing the price from 90 to $1.10, quantity sold is now a lot lower than before. So this area A is indicating you the loss in revenue because of lower quantity sold. But at the same time, because I'm charging a higher price, I'm also getting these additional 20 cents. So $1.10 minus 90 cents is 0.20 or 20 cents, I'm getting 20 cents additional for all of these units sold. So the sold units are now 900. And area C is indicating this additional revenue because of the higher price being charged. So there are two opposite effects on revenue. Total revenue is increasing because of the price effect, because I'm charging a higher price, and total revenue is decreasing because of the quantity effect. Because in this particular scenario, as price has gone up, I've lost some sales. So area A is the overall loss in revenue because of lower quantity, and area C is the gain in revenue because of higher price received by the sellers. Overall, the new revenue would be area B and C, because we are selling the good at $1.10 and we're selling 900 units of the good. Initial revenue was area A plus B. The new revenue is area B plus C. So if I write it like this, old, new, and then change in total revenue. The old revenue or the initial revenue is A plus B. The new revenue is B plus C. And the change, we have lost area A because of the lower quantity sold, but we have gained area C. So one of these is always negative. In this case, the price effect is positive and the quantity effect is negative. Depending upon which area is bigger, that will determine what happens to your total new revenue. If you're working with a good which has elastic demand, now the quantity effect will be the stronger one compared to your price effect. So whatever happens to revenue, that will be determined by the quantity effect over here. In our case, price was going up, quantity demanded or sales were going down. So if you're working with elastic demand, total revenue will decrease. If instead you were working with a good which has inelastic demand, now price effect is the dominant one. Now if price effect is dominant and price is going up, that means the total revenue will also increase. So price effect is a stronger one and it pushes your revenue up. And if the demand is unit elastic, here we'll see that the quantity effect is exactly equal to the price effect. So for a given percentage change in price, quantity demanded will respond by the exact same amount. So it offsets the price effect completely. So total revenue will not change in this case. Price increasing by 10%, let's say, will cause quantity demanded to also decrease by the exact same amount. Not more than that, not less than that, and therefore your total revenue will not change. Some food for thought over here. We're assuming that the elasticity of demand for eggs is estimated to be 0.1. Note this is an absolute value, so we're ignoring the negative. If egg producers raise their prices by 10%, what do you think will happen to their total revenue? Now, will it increase, decrease, or it will not change? So what's the information given to us? You note that the elasticity of demand is 0.1, so it is less than 1. We know whenever it's less than 1, the demand curve is relatively inelastic. So we're working with inelastic demand where the price effect is the dominant one. For any given change in price, now quantity demanded will respond by less than that. And what are they doing? They're increasing their prices by 10%. So we know price is going up, quantity demanded will be going down. But now, knowing that this is inelastic demand, price effect is the dominant one. So you can easily predict that total revenue will increase. Another way to look at this question is you can also, be asked by how much will quantity demanded change given this situation. So we know elasticity of demand is the ratio of percentage change in quantity demanded to the percentage change in price. And elasticity of demand is given to us as 0.1. Price is rising by 10%. And you're looking out for what happens to your quantity demanded. So for a 10% change in price with an elasticity measure of 0.1, it's telling you that quantity demanded will respond by only 1%. 10% times 0.1 is 1. So that's telling you quantity demanded in this case will fall by 1% because prices were rising by 10%. Next, let's compare slope and elasticity of demand for a linear demand curve. Now, a lot of students confuse the two. Slope is the rise over run or the rate of change in your y variable with respect to your x variable. In our case, our variable on the y-axis is price and the variable on the x-axis is your quantity. So slope is simply the change in price between any 2 points divided by the change in quantity across those 2 points. So slope for a linear demand curve is simply change in price over change in quantity, and it will be constant, does not change for a linear demand curve. Is slope and elasticity the same thing? Of course not. With elasticity, we are not looking at the absolute changes, we're looking at percentage changes. And also the ratio is reverse. We don't have percentage change in price in the numerator, instead we have percentage change in quantity. So they are completely different from each other. Elasticity of demand is percentage change in quantity demanded divided by the percentage change in price. But let's go a bit further and explore the relationship between the two. So I'm going to expand this formula, and that tells me percentage change in quantity is change in quantity divided by the average quantity, and percentage change in price over here is change in price divided by the average price. Rearranging it further, we have change in quantity over change in price times the ratio of average price to average quantity. Now, what is this part? This is similar to slope, but not the same as slope. In fact, this part is the inverse of the slope. So I can rewrite it as elasticity of demand, essentially inverse of your slope times average price over average quantity. Let's look at what this tells us about elasticity of demand as we move along a linear demand curve. Note that the slope is constant for a linear demand curve, so 1 over the slope or the inverse of the slope will also be constant whether we are moving between A to B, B to C, or C to D. So this part is not changing along this linear demand curve. But what about this ratio over here? Note when you're in the upper segment of the demand curve, so let's say at a point like A or B or somewhere in between, we're working with very high prices and correspondingly low quantities. So high prices and correspondingly low quantities. And in fact, if we move further down this demand curve, the opposite starts to happen. Between points like C and D, in the lower segment, I'm working with high quantities corresponding to low prices. So if, for example, if we are calculating the elasticity of demand between A and B, we have inverse of the slope between A and B times average price and average quantity. If you're working with high prices, average prices are going to be typically higher. If you're working with low prices, average prices are going to be typically lower. So in the upper segment of the demand curve, your elasticity of demand to be typically higher compared to any 2 points which are lower on the demand curve. Now here on between C and D, low prices, high quantity makes the ratio smaller and pushes down your elasticity of demand. So higher the points on the demand curve, higher is the elasticity measure. Lower we are on the demand curve, lower is the elasticity measure. In fact, we can segment this demand curve into 3 particular parts. We will have a point on the demand curve where elasticity is exactly equal to 1. This is the elasticity in its absolute value, so we're ignoring the negative. Then the upper segment of the demand curve, because you can see higher the prices we are working with corresponding to low quantities, elasticity measure is increasing. So we have a segment of the demand curve which has elasticity greater than 1. So the upper segment has high elasticity measures, and we can say this segment is elastic demand. And below this particular point where you had unit elasticity, now you're working with low prices and high quantities. So elasticity measure is being pushed down below 1. So this segment is where we have inelastic demand. Elasticity of demand is now less than 1. So 3 segments of your linear demand curve. Unlike slope, elasticity is not constant. The higher we are on the demand curve, the more is the measure of elasticity. Lower segment, lower is the elasticity measure. At these extreme points, vertical intercept, elasticity is equal to infinity. And at the horizontal intercept, because elasticity keeps on decreasing, elasticity is equal to 0. So I can assume the vertical intercept is 7. That's telling me that if price rises above 7, price elasticity of demand is 0. Why? Because quantity demanded will immediately drop to 0. At any price higher than 7, consumers are not willing to buy any units of this good. We can now also look at another example. In this case, I have a table example over here where this is your demand schedule. You can see price is falling from 7 to 0 and quantity demanded in response to these lowering prices is rising. So that's your demand schedule. We have total revenue in the third column, and then we have percentage changes in prices and percentage changes in quantity demanded in the next 2 columns. Taking the ratio of these two, we have also already calculated our elasticity measures as we move across this linear demand curve, and we're moving downwards along the demand curves. So let's observe what happens as we move along this demand curve. Now note, if price is falling from 7 to 6, quantity demanded is rising from 0 to 2. In terms of average price, this is a high average compared to a low average quantity. In terms of elasticity measure, we are working with a relatively high elasticity measure. So somewhere over here is between 7 and 6. As you keep on going down, your average prices are going down, but your average quantities are rising, and that's pushing your elasticity measure down. And this is essentially what we're looking at over here, a segment where the demand curve is at unit elastic point, so somewhere between 4 and 3. Below 3, the price of 3, you can see we're working with inelastic demand, and above 3, we're working with elastic demand. So we could segment our demand curve into again 3 parts: unit elastic, inelastic, and elastic. Another way to look at this observation is what type of percentage changes do we see? With a jump of from 0 to 2, that's a significant percentage change in quantity of 200%. But a jump of 7 to 6 is a small percentage change in price. So when we are working with high prices and low quantities, percentage change in quantity is the dominant one, making your demand elastic. In the lower segment of the demand curve, we are jumping from quantity of 12 to 14, which is only a 15% change in quantity demanded, corresponding to a price fall of 1 to 0, which is a 200% decrease in price. So lower the segment that you're working in, percentage change in quantity becomes smaller and percentage change in price becomes dominant. So different ways of looking at the same thing, but the idea over here is that elasticity is not constant for a linear demand curve. Higher the segment of the demand curve that you're working in, the more elastic is the demand. Lower in the lower segment of the demand curve, when you're working with low prices and high quantities, demand is relatively inelastic, less than 1. And then of course you have a third point or third situation somewhere in the middle where elasticity will be exactly equal to 1. Percentage change in quantity demanded over here will be exactly equal to the percentage change in price. Let's look at how revenue responds to this linear demand curve. And in my next example, I'll be using the textbook example, so with slightly different numbers than the one we just saw. Now, this is our textbook example, but very similar. We have price and quantity demanded, or the demand schedule given to us. We can calculate the total revenue for any given price and quantity combination. Note, when price is 0 and quantity demanded was maximum at the horizontal intercept, total revenue is 0. Total revenue rises as price rises. So price is rising from 0 to all the way to 5, and total revenue is at its maximum. And as price keeps on rising, total revenue then falls again to 0. So we can see total revenue is what we call a maximum function. Another way to look at this would be start at the highest possible price, or the vertical intercept of 10. As price falls, note what's happening to total revenue. It is rising. It is reaching a maximum, and then after that it starts to decrease. So total revenue again is your maximum function, whether you start from the vertical intercept or from the horizontal intercept. So let's superimpose our demand curve. Our demand curve is downward sloping, and for any given price quantity combination, we can correspondingly calculate our revenue. So you can see our revenue is maximum at the unit elastic point, but before that, if price is decreasing, we're in the elastic segment and total revenue is increasing. In the inelastic segment, which is the lower segment of your demand curve, total revenue starts to fall. So let's make some logic out of this. Why is it increasing, reaching a maximum, and then decreasing? So I'll start with a highest possible price. So when we are moving from these high prices towards these lower prices, so somewhere from 10, 9, 8, and then all the way down to 0. What's happening over here? We know in the upper segment of the demand curve, we are working with quantity effect that is dominant. And as price decreases, it causes quantity demanded to increase, but this is the dominant effect. So your total revenue, which is P times Q, must be rising. Total revenue therefore was initially 0, but then it starts to rise. Total revenue keeps on rising as price is falling till we reach the unit elastic point. At the point of unit elastic demand, percentage change in quantity demanded is exactly equal to the percentage change in price. Now when price falls, quantity demanded responds by increasing, both effects are exactly equal to each other, so they're offsetting each other, and hence your total revenue is not changing, and therefore total revenue has reached its maximum point. So whenever we are at the unit elastic point, revenue is at its maximum possible for this given market demand curve. And then in the third segment, as price continues to fall, now price is falling, quantity demanded is responding by increasing, but now because we're in the inelastic segment, price effect is the dominant one, and therefore it pushes your revenue down, and total revenue is now decreasing. So as we work through the demand curve, starting from the top all the way to the bottom, revenue increases because of elasticity of demand being elastic, reaches a maximum because of being at the unit elastic point, and then total revenue decreases because the price effect becomes the dominant effect. And again, it decreases all the way to 0, where you are corresponding to the horizontal intercept on your demand curve. If we can work with prices going down, we can also work with the same scenario, but now in the opposite direction. So I have the same diagram from the textbook. We have our linear demand curve, and we want to see what happens to revenue as we are increasing price and going all the way from 0 to this maximum of, let's say, 10. Now at 0, quantity demanded is maximum possible, but revenue is 0, because remember, total revenue is P times Q. So if price is 0, revenue is automatically 0. So now we are starting at 0, and gradually we are going to increase price. As price goes up, quantity demanded will fall. So you can see quantity demanded is falling as price is going up. But note, in the lower segment, we're in the inelastic segment. So which effect is dominant? Price effect is dominant. So when price goes up and quantity demanded is falling, it's causing your total revenue to increase. So you can see as price is going up, quantity demanded is falling, our revenue bars, these green bars over here, they are rising. This keeps on happening till you reach the unit elastic point. At unit elastic point, both effects are offsetting each other equally. So revenue is neither rising nor falling. So revenue has reached its maximum point. As we push the price further up beyond the unit elastic point, price is going up, quantity demanded is falling, responding to this higher price. But now we're in the elastic segment. So quantity demanded is falling by more than the increase in price. So quantity effect is the dominant one. And this is now causing your revenue to decrease. So revenue was initially increasing, reached a maximum, and now in the elastic segment, as price is rising, revenue is decreasing, because whatever happens to quantity demanded, the same is happening to total revenue. So total revenue will fall, and eventually reach 0. So we can see that with a linear demand curve, your total revenue will always be a maximum function with a downward sloping linear market demand. And what happens to revenue essentially comes from the fact, can be determined by what type of elasticity measure are we working with.